Hi everyone, this is your math guru. In this video, I'm going to use trigonometric ratios and Pythagoras Theorem to find the angle BAC or X. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. In the first example, we have a cuboid given with the following dimensions, and in order to find the angle BAC or X, I need to find the value of Y as shown. And in order to find the value of Y, I'm going to use the right angle triangle AC. I'm going to call the last point R, such that if I draw out the triangle, I'm putting in the dimensions. I have my right angle at R. I have A and C. I have AR 10 centimeters. I have RC 4 centimeters. Then I'm to find AC, which is Y. Using Pythagoras Theorem, I have AC squared equals CR squared plus AR squared. That's Pythagoras Theorem. Therefore, putting in the parameters, y squared equals CR squared, that's 4 squared, plus 10 squared. 4 squared is 16 plus 10 squared, 100. So therefore, y squared is equal to 116. And to find the value of y, I'm going to find the square root of both sides. Therefore, my y equals the square root of 116, which is 10.77 centimeters to 2 decimal places. So now that I have the value of y, I will go ahead and move to the right angle triangle ABC as shown. So therefore, if I draw that out, I have the right angle triangle ABC. I have my A, which is my X, B and C. The right angle is at C. AC is Y, which is 10.77 centimeters. Then I've been given BC to be 3 centimeters. To get the angle at A, which is X, I'm going to use my trig ratios. My trig ratios with the acronym SOHCAHTOA, that helps in knowing the ratio for each of the trig values of trig functions. So to start with, or to determine which of the trig ratios to use, I'll start by naming all the sides of my right angle triangle. Note that the side facing my angle will be my opposite. The side facing my right angle, as shown, will be my hypotenuse, and the last side is my adjacent. So therefore, because I know I'm looking for my angle, and I have my opposite and my adjacent, what that means is I'm going to use my tan. So the tangent of X equals opposite over adjacent, as shown in my acronym at the top, and that is equal to, opposite is 3 centimeters over adjacent 10.77 centimeters. Therefore, in order to find my X, I'm going to move my tan to the right hand side, and once the tan crosses the equal sign, it becomes arctan of 3 over 10.77. To find the arctan is press the second function button on your calculator, and then you press the tangent button. So second function of tan will give you arctan, and if you punch that in, you're going to have 15, or 15.56 degrees. So that is the value of the angle BAC as shown. Let's look at the second example. In the second example, I have this similar cuboid, and to find the angle BAC or X as shown, I'm going to start with the right angle triangle AC. I'm going to type that again, R, such that if I draw that out, Note that all the corners of a cuboid at right angle. So even though that wasn't given, I know that the angle at R is a right angle, which is 90 degrees. So I have A, R, and C with the dimensions 5 centimeters and 12.5 centimeters. So the first step is to look for or find the value of AC. I'm going to use my Pythagoras Theorem that states that the square of the longest side, or the side facing my right angle, AC squared, equals to the sum of the square of the other two sides, AR squared, and that's by Pyth theorem. So therefore, AC squared equals CR, that's 5 squared, plus AR squared, 12.5 squared. And that's going to give me 25 plus 12.5 squared, that's 156.25. Therefore, AC squared equals, if I add that together, 181.25. And to find AC, I just need to find the square root of both sides. Therefore, my AC equals square root of 181.25. That's 13.46 centimeters. So I'm going to put that 13.46 centimeters to 2 decimal places. So now that I have the value of AC, I'm going to move ahead. I'll go ahead and use the triangle ABC as my next reference. So if I draw that out, that's ABC. The right angle will be at C as shown. So I have C, B, and the distance BC, that's 2.5. And the distance AC, that's the value I got, that's 13.46, all in centimeters. I'm to find the angle BAC, which is also equal to X. So like I did earlier, I'll start with my trig ratio, that's the acronym SOHCAHTOA, in order to determine which of the trig function to use. So labeling the sides of my right angle triangle, the side facing my angle, that's my opposite. The longest side, or the side facing my right angle, is my hypotenuse, and the third side is my adjacent. So therefore, if you look at what I have, to find the angle X, I have the values opposite and adjacent given, and the trig function that uses opposite and adjacent is my tangent, that's my TOA. So therefore, tan of angle X, or angle BAC, equals my opposite over my adjacent, which is equal to 2.5 divided by 13.46. To find X, I'm going to move my tan to the right hand side, and that becomes arctan. That's the second function button of your tangent button on your calculator. So I have 2.5 divided by 13.46, the same. Therefore, X will give us 10.52 or 10.52 degrees. Thanks for watching. Bye.